Hello students, today we're going to do Chapter 2, Section 1. Matter. Matter has anything that has mass and takes up space. There are two types of matter. There's pure substances, and then there's another type that we'll talk about in a few slides. But for pure substances is matter that has the same composition throughout, which means it has the same type of particles throughout the entire thing. And there are two different types of pure substances. First, we have an element. An element is a substance that cannot be broken down into simpler substances. So you can't break elements down any further. Atom. Atom is the smallest particle of an element. So if elements have only one type of atom, elements are found on the periodic table. So if you look in your agenda or a periodic table on the internet, those are all your elements. If you're looking at one of those, this has symbols on it, and it always has one or two letters, and the first letter is always capitalized. For example, here we have Cl, which is chlorine, Al, which is aluminum, and Fe, which is iron. So the first letter is always capitalized. It doesn't always have to have two letters. It can have one letter. For example, capital H is hydrogen. The next, so you already have the two types up here in the pure substances. So the second type of pure substance is compound, which is a combination of two or more elements joined in fixed ratios. So they're chemically combined together, they're attached to each other in a fixed ratio. The properties of a compound differ from the properties of the elements that make them up. They are different. For example, if we had water, and water is a compound and it's made up of hydrogen and oxygen. Hydrogen and oxygen are both gases at room temperature, but water is a liquid at room temperature, so they are different. This always has at least two capital letters in it. Some examples are water, which would be the H2O, so you have two capital letters, the H and the O, and then table salt, which is NaCl. You've got two capital letters, N and C. Another thing about pure substances is they cannot be broken down by physical means. We'll talk more about those physical means in the next set of notes. The other type of matter that we talked about, so we talked about pure substances. The other type of matter is mixtures. Mixtures are any substances combined in any ratio. So a compound had two elements combined in a fixed ratio. Mixtures are any kind of ratio. These can be broken down by physical means, which again we will talk about on the next set of notes. There are two types of mixtures. There's a homogeneous mixture. A homogeneous mixture is evenly mixed, so it is difficult to distinguish the different parts. And homo means same, and the genus means kind. So that's how we get that it looks homogeneous. You can't distinguish the different parts. It looks like the same thing throughout the whole thing. A homogeneous mixture is also known as, or AKA, a solution. And a solution is when a substance combines to form a homogeneous mixture. So the homogeneous mixture and solution are synonymous with each other. Next we have heterogeneous mixture. That's the second type. And those are when parts of a mixture are different from each other. Hetero means different, and then the genus again means kind. There are two types. There's a suspension, which is a heterogeneous mixture that separates into layers over time. And there's a colloid. A colloid contains particles that are intermediate in size. So let's look at suspension, colloid, and solution a little bit more looking at this table. Make sure you put this table in your notes. So a solution, like I said, is a homogeneous mixture. It is the smallest particle size. It does not separate into layers, and it can't be filtered. Filtered is kind of like when you're separating noodles, you're filtering out the water. Solutions can't be filtered. It doesn't scatter light, and I will explain scattering light more with a demonstration in class. And example of solution would be salt water or Kool-Aid. Both of those look like one thing throughout. The heterogeneous mixtures are your colloid and your suspension. So we've got colloid that has the middle size of particles. This also does not separate into layers, and it can't be filtered, but this can scatter light. An example of this would be fog. And then lastly, we have suspension, which is heterogeneous. It is the biggest size particle, and it can separate into layers, it can be filtered, and it can scatter light. And an example of this would be muddy water. Muddy water is, if you notice, after a certain amount of time, the mud's going to separate from the water, and the mud will sink to the bottom. That is it for today's notes.